Now that we've done an example where we've added two functions, let's do an example where we're doing all of the things that we can do. So here we have, oops, I'm going to have to turn on my pen again. We have f of x is equal to x squared minus 9 and g of x is equal to x plus 3. The first thing we want to find is f plus g of x. So just like we did in the last video, we're going to take f of x, x squared minus 9, and we're going to add g of x, x plus 3. Now, in this case, we do have like terms. We have the negative 9 and the 3. And it's kind of customary or tradition to write polynomials in descending order of the exponents. So we're going to write this as x squared plus our x, and then negative 9 plus 3 gives us negative 6. So our final answer would be x squared plus x minus 6. So adding two functions, really not too difficult. You're going to take the first one, add the second one, combine any like terms. Now we have to be a little more careful with subtracting two functions. Now we want f of x minus g of x. And we're going to write down f of x, the first one, x squared minus 9. And we want to subtract g of x. Now, since g of x has two terms, we need to put g of x in parentheses, and we're going to have to distribute that minus. And you can think of that like a minus 1. So we'll write our x squared minus 9, and then we'll do negative 1 times x, so negative x, and negative 1 times 3, so minus 3. Okay, so with subtraction, you do need to be careful. Write your second term in parentheses, so you distribute the negative sign. And then we'll combine our like terms, x squared minus x minus 12. Okay, the next one we want to look at is f times g of x. And this one, you know, it never hurts to write all of your functions in parentheses. When we're adding, the parentheses don't matter. When we're subtracting, the parentheses really only matter for the second term. Here when we're multiplying, we're going to put parentheses around our x squared minus 9 and our x plus 3. And these are called binomials because they have two terms, and when we multiply binomials, we use FOIL. Remember, first, outside, inside, last. So our first two terms will give us x cubed, the x squared times the x. Our outside terms, x squared times 3, so plus 3x squared. The inside terms will give us negative 9x, and our last terms will give us negative 27. I just like drawing the crab claw this makes. Okay, so here we would look to see, are there any like terms? And there's not, so that's our final answer. We're leaving these are going to look like functions. They're really new functions we're creating from the old functions. So for example, you know, I could ask for f times g of 1, and you would then take what we just found and plug in 1, but only if you're asked to plug in a number. So f times g of 1 would be 1 cubed plus 3 times 1 squared minus 9 times 1 minus 27. Should have grabbed a calculator. This is 1 plus 3 minus 9 minus 27. This is going to be 4 minus 9 minus 27, which will be negative 5 minus 27, which will be negative 32. Okay, so that would be f times g of 1. But if you're just asked for f times g of x, you can stop with the expression. Okay, f divided by g of x, we're going to write a fraction. We're going to put f on top, x squared minus 9, and g of x on bottom, x plus 3. Now, one thing I'll just point out, and we'll talk about it in another video as well, is think about the domains of f of x and g of x. So f of x, the domain, this is a polynomial, so the domain is from negative infinity to infinity. And g of x, same thing. It's a polynomial, so the domain is from negative infinity to infinity. But when we divide two functions like this, what's the domain of f divided by g of x? Well, now, since it's a rational function now, we're dividing, we have to take the denominator, x plus 3, set it equal to 0. We would get x equals negative 3. And remember, for rational functions, this means negative 3 cannot be in the domain. So the domain would be all numbers except negative 3. And we would write that as negative infinity up to negative 3, parenthesis, union, negative 3 to infinity. Okay, and the last one, there's no reason why you can't use the same function twice. We want g times g of x. You know, we could write that as actually g squared of x. We don't see that so often, but especially if you're taking pre-calculus, when we get to trig functions, we'll sometimes write the squared like that. So here we're going to take g of x, which was x plus 3, and multiply it by itself. And what do we need to use here? FOIL. So we're going to FOIL it. So first term's x squared. Outside we would have x times 3, or 3x. Inside 3x. And last, 3 times 3 is 9. Okay, so x squared plus 6x plus 9. Okay, so there's lots of different things we can do with functions. And when you're multiplying, just be careful about your parentheses and foiling. Remember, when you're subtracting, you also need to distribute that negative sign.